Back. I hope we had a great break. I want to say thank you for your flexibility. I know it was a little bit unusual. I wasn't here on Wednesday for your test. I wasn't here on Friday for the day on Pythagorean theorem and some laws about exponents. So I appreciate your flexibility. I understand that Jessica covered the class on Friday. I hope things went really well for you guys. I didn't get a chance to check all of the homework, but the homework I did check, it seemed like people were solid on those laws of exponents. I'll check the rest of the homework in class later today while you're doing group activity stuff. So before we jump into the new material, which starts here on page 9, there are just a couple of announcements that we need to talk about. First one is right here. Currently, elections are happening on campus for your GCC student senators. There are 4 Senate positions, 1 Senate president position, and 1 student trustee position that you need to elect. Elections are happening between today and Wednesday, although they went live a little bit later this morning than they were supposed to, so the deadline has been extended to Thursday noon is the last time you can vote. You're going to log into Moodle between now and Thursday at noon, and you're going to vote. And if you don't know anything about the people that are running, no problem. The information is right there when you log into Moodle. You will see what each person's platform is, and you will pick the people that you think are most aligned with what your vision is as well. Additionally, there's a very important referendum regarding mass purg that's going to be on this ballot. I'm guessing most of you do not know what mass purg is. Is there anybody who can fill us in on what's going on with this? Okay, so I'll say this. Mass Purg is an organization that you pay $9 every semester for as a student here at GCC. It is mandatory. It's on your tuition and fees bill every semester, $9. Mass Purg stands for lots of things that the Student Senate here believes in, but the Student Senate feels that they have seen very little return on the $10,000, that's all of those $9 fees every semester for the last few semesters, that you guys have paid. The Student Senate would like to stop having this charge of $9 per semester be mandatory. So you're going to get informed about this. Again, I think there's information about it up on the Moodle when you log in. Yeah? I think that you have to go out of your way. Yeah, so you have to go out of your way. So the default is that you're going to pay it. Right. So the question here is, can we stop making it the default that you pay it? So the Student Senate would like you to eliminate this $9 mass purg automatic thing. I'm not saying whether you should or shouldn't. I'm saying you should become informed and then make an informed choice. Okay. So log into Moodle. There'll be some information. Any questions on this? Again, Thursday noon. That's the deadline for doing all of this voting. Okay, that is that. Next thing, let's talk a tiny bit about the tests. I'm going to make this a little bit bigger. Page width. Okay, so on your test, you'll have a box that you have not seen before because I didn't put it on the quests, but I want to explain, be really clear what all of these numbers mean. Your homework average is only based on the first 10 assignments of the semester because I was out. I know that some people had some homework they wanted to submit to me, but I wasn't here on the day of the test. So I didn't want people to lose points on that because I wasn't here yet. So it only goes up to the homework, including everything up to the second quest. All right. The number that sits here in your quests is the average of the 2 quests that you have gotten. Okay. Double check that. You've taken 2 quests. I added them together and divided by 2. Make sure I did it right. The next number is your test grade. It should agree with the number that is right at the top of your test. You don't have a grade on the final exam yet. In order to merge all these numbers together and give you a snapshot grade for what you would get if the course ended today, let's see. Normally it's 100%, but what percentage have you actually seen so far since you haven't seen the final exam? 85%. So what I had to do was take a number out of 85%. And that's what I did here. You can double check my arithmetic if you want, but that's the formula that I used to figure out what your snapshot grade would be. So right in here, you'll see some letter and some number, and it's based on this formula right here. So that's the out of 85. Some information about this particular test and you guys who took this test. The high grade was 100, second highest grade was a 98. The median and the mean were very close to each other, right around 80. So if you did better than 80, you're in the top half of the class. Lower than 80, you're in the bottom half of the class, just to give you a sense of where you are. Now, I want to be really clear. We said this on the first day of the semester. It's on the syllabus, but I got to be really clear. There is no grade of AD awarded in Math 106. It's not just talking about me or this class. It's any Math 106 class. D is not a legal grade for me to award. What does that mean? Well, it used to mean that anything under 63 was an F, and anything between 63 and 70 is a D, still passing, not super, but passing, but not in Math 106. So what that means is that it's not a D, it's an F. So if you want to pass this class, you need to get above 70, right? That 63 to 70 window is not passing, not in Math 106, also not in Math 105. So 70 is the target number, bare minimum, in order to get through this class and be eligible to take the next math class here at GCC. If you have something that is less than 73 right now, then I have sent you what's called an early progress report. It went to you, it went to your advisor, just my way of checking in and saying, hey, either you're very close to not passing or at the moment you are not passing, and here are the things that you can do to change that before it's too late, okay? Any questions on any of this? Okay, so let's go here, back to page 9, and we'll start doing some math. So we're here in the middle of page 9, and we will begin with Katrina in the back. Katrina, number 1. Okay, so let's go back a few pages. This is something that you saw with Jessica, and we'll go back and find this chart with the pattern right here. Page 5. Okay, so on page 5, there's this pattern on the right-hand side. 3 to the 4th is 81. What does that mean? 3 times 3 times 3 times 3 is 81. Yes? 3 cubed is 27. 3 times 3 times 3. Yes? 3 squared, easiest one, that's 9. 3 to the 1st, just a single 3, that's 3. Then we get to something that maybe was new for some of you last class. 3 to the 0. What does it even mean to take a number, multiply it by itself 0 times? I know what 3 squared is. It means give me 2 3s and multiply them. What does it mean when I say give me 0 3s and multiply them? Well, we define it to be 1. Why do we do that? Because we like this pattern right here. How do you get from, say, 27 to 9? What can you do to 27? You can divide it by 3. What can you do to get from 9 to 3? You can divide by 3. We believe this pattern, right? Because going up the ladder, you multiply by 3. So going down the ladder, divide by 3. So if I'm going to put anything right in here, what should it be? Well, it should be take that number and divide it by 3. And what do you get? You get 1. So that's why we define 3 to the 0 to be 1. It's really tempting to call it 0, but it's not. If you call it 0, you're not going to be consistent with this pattern. So 3 to the 0 is 1. How much is 5 to the 0? It's also 1. And 7 to the 0 is 1. And any number to the 0 is 1. And that's this thing over here. Okay? Any number to the 0 is 1. You saw that with Jessica Friday a week and a half ago. Today, one of the things we're going to talk about is negative exponents. So last time you saw what a 0 exponent means, it always means the answer is 1. How do we get to the negative exponents? Well, let's just keep going down the list. We've got this pattern. So again, how do you go from one number to the one below it? Divide by 3. That's the pattern here, right? So then going from here, hello. I do. Could you give me just a couple of minutes? Just have a seat in the studio. I'll be right over there. Okay. All right. So how do we go from this number 1 to the next number? We divide by 3. Yes? So you take 1 and you divide by 3 and you get 1/3. And you take that number and you divide by 3 and you get 1/9. And you keep dividing by 3 because that's the pattern. But what's the pattern over here with the exponents? Well, it's 3 to the 4th, then 3 to the 3rd, 3 to the 2nd, 3 to the 1, 3 to the 0. What's the next number? Is 3 to the -1. So what we just did was define 3 to the -1. This idea of knowing that 3 squared means 3 times 3, it really breaks down for negative exponents and for 0 exponents. So we can't rely on the old knowledge of what 3 squared means. We need something new, and we're going to follow this pattern to figure out what that new thing is. If this pattern is going to work, we have no choice but to find 3 to the negative 1 to be 1 over 3. 3 to the negative 2 is 1 over 9. And 1 over 9 is really 3 squared, yes? And this is really the pattern that we're after here. And it looks like Jessica talked a little bit about this as well. 3 to the negative 2 is 1 over 3 squared, which is 1 over 9. So as another example, 2 to the negative 3rd power. What does it mean? It always means 1 over. Always. If you see a negative exponent, it means 1 over. Nothing more and nothing less. 1 over what? 1 over the thing, but with a positive exponent. That is what 2 to the negative 3 means. The negative says 1 over, and then you just copy the thing down, but make it a positive exponent. How much is 2 cubed? 8. So 2 to the negative 3 means 1/8. It's a very mysterious thing, but it just follows from that pattern. Ultimately, I don't want you to have to write the pattern every time. I just want you to know, okay, 2 to the negative 3 means 1 over 2 to the positive 3, and just make it like an automatic kind of thing, but it follows the pattern. It came from something. So in general, we've got this thing here circled in purple, x to the negative n. What does it mean? It means 1 over x to the positive n. And so we're going to start today with that formula right there. So let's go again back to page 9. And I will circle the same formula that we just saw. And it says x to the negative n is 1 over x to the positive n. And then going the other direction, if you have a negative exponent but it's already downstairs, well, we're not going to go through all the details here, but what does this guy mean just by itself? According to, we've got it here in purple. What does x? Yeah, this means 1 over x to the n. Yes? Yeah, that's what it means. But it's in the bottom of a fraction. So if I want to put that fraction back, there's still a 1 on the top. That's this one. Yes? And it's a fraction within a fraction, and we'll spend some time dealing with those this semester. You'll spend more time in 107 dealing with fraction in a fraction. But suffice it to say, it turns out this is really just the same as plain old x to the n. No 1 over 1 over. It's just x to the n. So if you have a negative exponent and it's upstairs, you move it downstairs. If you have a negative exponent downstairs, you move it upstairs. So let's see if we can do a couple of quick examples here in number 2. Can we go to Davis for number 2? Okay, so the reciprocal, what does that fancy word mean? It is opposite in a sense. So yeah, we did do negative reciprocals for perpendicular lines. So reciprocal meant you take your fraction and do what to it? And you flip it. That's what reciprocal, and it is a multiplicative inverse. So what does it mean? I have 2 cubed. I'm just going to flip it over and make it 1 over 2 cubed. I'm not saying that's what's equal to 2 cubed. 2 cubed is just 8. But this says find the reciprocal. So reciprocal means flip it. But now what I want to do is write this with a negative exponent. I want to write it with a negative exponent. If it's in the denominator, it came from a negative exponent up there. So 1 over 2 cubed is the same as 2 to the negative 3. How come? Because in this purple thing that I've circled, as soon as you see a negative exponent, what do? Where do you throw it? You throw it downstairs. So it's already downstairs. Somebody threw it down there. It must have come from a negative exponent, right? This is just kind of going the other direction. Let's do a couple more. Let's do part C. This question says find reciprocal. So I'm going to put x to the 4th on the bottom, just because it says find reciprocal. And where did it come from? X to the minus 4. Agree? If you have a negative exponent, you can throw it downstairs and make it positive. This is just on doing that. Okay, let's try going the other way. Let's do the reciprocal of this guy, 1 over 4 to the negative 2. So somebody threw it downstairs, which means it must have come from up here. What power up there would do it? It's positive 2. It's actually, all right, a little more detail. We know that whenever the number is downstairs, let's take a look at this guy. This 2 cubed, we brought it up and made it 2 to the negative 3, right? So apparently whenever it's down there, you can bring it up and make it negative. So I'm going to take this guy, I'm going to bring it up. So it is 4 to the negative 2. That's just bringing it up. But what do I still need to do to it? I need to make it negative. So I'm going to make that negative 2 negative.
So why would it just be 1 over 4 squared?
So 1 over 4 squared, if I wanted to rewrite that, I can say, okay, it came from downstairs. Somebody threw it down there because it had a negative exponent to start. But if it's down there and it's already negative, then bringing it back up actually throws another negative in the front of it. I'm going to give you shortcuts down here. We're just going to worry about the shortcuts. Let's do one last example here, D, and then we'll look at the shortcuts. What did we figure out from B? If you have a negative exponent downstairs, you brought it up, and what kind of a number did you get in the exponent? Positive. Negative exponent downstairs becomes positive upstairs. Let's take a look at this guy. 1 over r to the negative 7. We're supposed to deal with a reciprocal of some kind, so let's write it. It's going to be kind of messy, but sorry, I don't need to do that. The reciprocal of this number, what do you do to the fraction? Flip it over, right? So r to the negative 7. You don't need to put the 1. I'll just put it so we really see we flipped over a fraction. That's what reciprocal means. And so it's just, as Michelle says, r to the negative 7. This answer is fine. If I wanted to, I could move it. What do you make it when you throw a negative exponent downstairs? R to the positive 7.
So I totally understand the process of throwing it downstairs. I'm sure that I could probably work with this and find the answer, but I'm having a hard time understanding why it works this way.
Yeah, so the why is difficult to understand. It just comes from that pattern. So if you like the idea that we can follow this pattern by dividing by 3 every time, then I think we gave good meaning to 3 to the for example, this 3 to the negative 2. Why is it 1/9? Well, it's 1/9 because we did a lot of calculating to get down there. So 1/9 is the only thing we can put here next to 3 to the negative 2 if we're going to follow this pattern. But apparently 3 to the negative 2 is 1 over 9, which is 1 over 3 to the positive 2. So I guess what I'm asking you to really focus on is that 3 to the negative 2 is the same as 1 over 3 to the positive 2.
Okay.
That's what the pattern says. Yeah, so the important idea, and here are the shortcuts, is that if you see a negative exponent, you move it. If you see a negative exponent, you move it and you make it positive. If it's just sitting up there by itself, you move it downstairs and you make it positive. If it was already downstairs, like some of the examples we saw, where did we go? This example, where was it? Downstairs? Here. If you see a negative exponent and it's downstairs, you move it and you make it positive. So whenever you see a negative exponent, you move it and you make it positive. If it was upstairs, you move it down. If it was downstairs, you move it up. That's what it says down here in number 3. We'll go to Davis. Oh, sorry, Davis read. Okay. Thank you. Let's go to the next page, and there are going to be a bunch of examples that I want you guys to work through. But the important thing here is movement. If you see a negative exponent, you move it to where it's not. This 3 to the negative 4, would you say that this thing is upstairs or is it downstairs in a fraction? Currently, it's upstairs. There's no fraction there, so if I wanted to make a fraction, I'd put it over 1, right? So if you want to make it a positive exponent, you move it. Move it to where it's not. Where it's not is downstairs. So it becomes 1 over 3 to the positive 4. It's always 1 over. And then 3 to the 4th is 81, so we have that. So what I'd like you guys to do is see if you can work through all of these parts up through L. There are answers here, but before you look at the answers, look to your neighbors. Let's see how far we can get on these. So it looked like folks had a lot of success until we got towards the later parts of these. So let's talk a little bit. Oh, nobody asked me about H, but any thoughts on H? CBS cannot be simplified. We have no property for adding x's with different powers. We can multiply them with different powers, but if you came up with x to the negative 12 or x to the negative 1 or really anything at all, it's not right. You cannot do anything with those two guys. Did I just put the 1 over on the second thing? Yeah. So I guess I want to highlight that there are things that look like you might be able to do with those powers, like add them or multiply them or subtract them. You cannot do any of those things. If you are so inclined, you can deal with the one guy that has a negative. What does it become? 1 over, right? So that answer is fine. If you are into lowest common denominators, you can make one fraction. We'll talk about those soon enough in this class, but not today. Let's take a look at part L. So one thing on part J first. Part J, it is very tempting to say, okay, this thing goes downstairs and this thing goes upstairs because we have negative powers. So this becomes 8c to the 8 over 4c to the 4. And we don't do that because the exponent is only touching what? The c. The exponent is not touching the 4 in the front. It's not touching the 8 in the front. So negative exponents are powerful in that they make things move, but they don't reach every place. They only move the things that they are touching, and they're only touching the c's. So the 4 and the 8 have absolutely no reason to go anywhere. It's only the c's that move. The c to the negative 8 moves upstairs, becomes positive 8. C to the negative 4 moves downstairs, becomes positive 4. But the numbers in the front don't move. Okay, last one I want to look at here is L. So if we take a look at L, we see a negative exponent inside of a negative exponent. So there are a couple of properties that I want us to use here. Let's go back a couple of pages to something else you guys did with Jessica. Where is it? Here we go. On page 4. So the first property that I want us to look at is this one right here on page 4. It says if you have one exponent on the outside of a couple of things multiplied together, you bring that exponent in to both of the pieces inside. It kind of looks like a distributive property. I'm never going to use that word here because distributive means something very specific and it's not this. But in a sense, you bring that power in and it hits everybody. So the example that you had over here, 3 times 4 cubed is really, you bring the 3 in to that guy and to this guy, and you end up with 3 to the 3rd times 4 to the 3rd. All right? So that's something you guys saw with Jessica. And then the other property we're going to use is this one. When you have a power raised to a power, what do you do with those powers? You multiply them. Multiply those powers. So if you have 3 to the 5, the whole thing squared, you multiply those powers and it becomes 3 to the 5 times 2, or just 3 to the 10. All right? So we're going to need to use both of those properties here on this last example. So let's take a look at L. So first thing I want to think about was this property. We had x times y to the m. And what do you do with that power on the outside? You bring it into both of them. So this is really x to the m times y to the m. Okay? So that's what we're going to do here. We have a 2 and we have an x to the negative 3. And both of them are going to get hit with what power? That -2 power. So this -2 goes up here, and it applies to this guy. I had to put extra parentheses there, so I really see the whole thing being raised to the -2. Okay. Next thing, 2 to the -2. Where do we move it? Downstairs. It becomes 2 to the +2. What do I put upstairs? 1 over. The other part, you could try to move it, but this is quite difficult because there's a negative power here and another negative power here. And you'll have to end up moving it and then moving it again. And it's complicated. It is possible to do it right, but it's also easy to get wrong. I want to remind you of one of those two properties we just saw from the other page. It said x to the m, the whole thing raised to the n. What do we do with the powers? Add them, multiply them. X to the m times n. So that is exactly what I want you to see right here. You have x to the -3, the whole thing to the -2. What do we do with the powers? Multiply them. X to the 6. And there's no reason to move it at all. It just became +6. We don't have to do anything. So it's a lot easier to deal with it that way than handling the negatives one at a time. So in this case, I would just multiply them. And then you can merge together to get one fraction. So I'll say that, so I've taught 106 once here, and it was several years ago. It was like 2.5, 3 years ago. It was in a summer. It was a long time ago. And one of the things that the students struggle with most were all of these properties with exponents. There are some that you saw with Jessica a week and a half ago that are kind of the straightforward ones that you say, oh yeah, I think I knew that, or that looks familiar. And then we bring in the negative exponents, and it just throws this whole wrench into things. And soon enough, we're going to have fractional exponents, like 8 to the 2/3. What does that mean? And so we're going to have all this whole pile of exponent laws, and they can become quite overwhelming. That was my impression from when I taught this course a few years back. So just putting it out there, I'm hoping that people can kind of stay on top of the homework. The homework that I checked for today looked quite good. So hopefully we can stay on top of it with these negative exponents for next time. All right, on the next page, there are a couple of applications, but to be honest, I would rather spend our time with you guys working on the group stuff on the next page. So can you jump to page 12? And in page 12, you will find a whole long group thing. And there's actually a second group thing on page 13. So you have your work cut out for you, but see if you can get through everything on 12 and 13. Yeah, all of this, and then the very next page. 12 and 13, there's an answer key for both, but best bet is to check with each other on the answers first. Raise a flag if I can help.